about myself. My name is Justin. I'm the Regional Manager for Life Technologies for Southeast Asia. And I'm honored to be invited to present at the 50th anniversary of the 103 Hospital. I'll take about 20 minutes, as I was told, to just give everybody a glimpse on how fast and how rapid the sequencing technology is moving today. A bit about life technologies. I think most of you in this room who have done research would have used our products one way or another. We are basically a merger of in Vitrogen as well as Applied Biosystems back in 2009. And together now we are known as Life Technologies, based in California, USA, and we have presence across the world, of course, in Vietnam with this tech. What we have specialized so far, we are a pioneer in sequencing technology. And that goes back to the 1980s, whereby we are familiar with capillary sequencing, or traditionally known as Sanger sequencing. That's the box that you see here. And today, as the technology advances, we are into what we know as next generation sequencing. And next generation sequencing, in short, is what this semiconductor sequencing is all about. If you think back in time, before when the IT industry or the computer industry first came about, a computer might be the size of a quarter of this room. That's the mainframe computer that we know. Today, we have laptops, we have PCs, we have phones. The technology is becoming faster. The tools, the instrument is becoming smaller. Likewise, we see that in sequencing. When it first came out, it was a Sanger sequencing, and that's, pretty much if you want to sequence a human genome, you will need multiple instruments running round the clock in a genome center. Today, with the PGM, which is known as the personal genome machine, you pretty much can get your genome sequenced in a couple of days at a fraction of what it costs to do a whole human genome in the past. And how we actually achieve this is based on the semiconductor technology. Exactly the same technology that you use in your phone, exactly the same semiconductor chip that is found in the PC. Instead of now having to look and differentiate different bases as we go about sequencing, what the platform does is actually just the detection of H+, hydrogen ion, pretty much like a pH meter. If you look at this, this is a typical blow-up of a semiconductor chip. What we have done is we have actually amplified DNA on the bits and throw the bits into the wells of the semiconductor chip. And sequentially start flowing nucleotides. We are talking about unlabeled nucleotides, just an A, T, C, G. And as we flow nucleotides in, what the chip does is to detect H+, which is actually a byproduct of the DNA polymerase reaction. So every time a nucleotide is incorporated by the DNA polymerase, H+ is naturally given out as part of this chemical reaction. What we have done in ion torrent sequencing is the detection of this H+. Therefore, we no longer have to differentiate whether is it A, T, C, or G. What we have done is sequentially flow nucleotides, look at the wells, see where the H+ are being released, wash away the nucleotides, in this case say A, we wash away the A, and we flow the